What's up, guys? I love extreme amusement parks, and I have been always wondering how my heart beats in the most exciting moments. For experimenting with that, I assembled a device that called Happiness Measurer. It is a standalone pulsometer that records every heartbeat and displays it on the monitor. So, I have two options. I can assemble a cardio monitor like those used in the hospitals and measure the heart rate with that. Or I can assemble a pulsometer for that. It will do just fine. I got a production model with analog device chip. It's an American electronic components manufacturer. The module is able to do ECG, electrocardiographic monitoring, with 3 electrodes. I assemble a prototype and stick the electrodes according to the instructions. Arms and legs. Here's how it goes. My heart rate graph looks realistic, with no noise. I could even show it to my cardiologist, but it works only when I'm standing still. It is the main problem of such modules. Special medical cardio monitors, on the other hand, use more electrodes, but are still movement sensitive. And they are expensive. I'll have to make my own pulsometer then. That American chip can function as a pulsometer, but I have to alter the circuitry for that. However, it is not possible on the module itself. So I have to unsolder the chip and place it on other board. The chip itself is very tiny and the contact sizing is 0.2 mm. So I make the board with film photoresist. It is possible to make the appropriate track sizing and spacing if I try hard enough. I design and print out the board on the film with the laser printer. Here's what it looks like. I make a textilite preform. First I lay it out, then I cut it with extra centimeter on the edges. Then I clean the copper from oxide film with sandpaper. I put the film photoresist in water, remove the protective film and put it on textilite. Now I roll it onto the textilite, first from the center to the edges, to get rid of the moist, and then cover the preform with paper and iron it at the lowest temperature. A good friend of mine borrowed me a self-made exhibitor. It's a remade scanner with a board that has a large number of UV LEDs. That's how it works. UV-sensitive photoresist hardens in areas exposed to UV, so it can't be washed off. I put a photo mask under the photoresist assembly. The transparent space are the tracks. When I switch the thing on, the photoresist starts to harden in the transparent area, so it can't be washed off. Look, here is a piece of photoresist. I put it in the sun and haven't covered it with the glass. The blue part was exposed to the sun, and the transparent part was under the glass. That's why it's better to store photoresist in the dark place, preferably in a refrigerator. Now I need to wash the preform. For that I use a soda ash dilution. A teaspoon per 250 grams of water. I store it and put the board in the dilution. With a bit of magic, the unaffected photoresist is washed off. Now I need to remove the extra copper with some chemicals. I need ammonium peroxide sulfate. I dilute it in the water and put the board in the dilution. A few moments later, the reaction has already started. The copper on the edges has dissolved. Well, I'd better leave it for another hour. The board turned out good. Even the 0.2 mm tracks are fine. Now I remove the unneeded photoresist left over with solvent. The board is almost ready. I only need to drill the adapter holes. I mark the holes with the tweezers so the drilling bit doesn't move around, and then drill it. The board is ready. Let me just cut off the extra bits. Now for the soldering. I remove all the needed components from the module and soldered them onto my board. I know that there are optical heart rate sensors, but they function well only if they are kept pressed onto the finger, wrist or neck. I think electrodes are more reliable in case of shaking or sudden movement. Now let's assemble the pulse logger. Iskra Nano Pro is the base. The heart rate is going to be output on Nexion display and recorded to an SD card, so that I can see the log later. The circuitry is powered by a portable charger. The module will be here. The portable charger's power button will be replaced with that switch, and the wires will go to the electrodes via sealed channels. All that in a 4mm plywood chassis. Well, I wanted to feel like a superhero. To stick the electrodes to my chest, put the display on the top, and look like an Iron Man. But when I tightened the belt on my chest and breathed, the box slipped down to my belly. At that moment I realized that I had to start jogging at least. Although it works, it looks stupid. I'll just strap it onto my backpack. Adrenaline release is an important means of protection for the human body. Adrenaline acts as a third party between the brain and muscles. When there is a danger for health, just for a few seconds, the adrenaline enters the bloodstream and stimulates muscles efficiency. The effect may last as long as an hour after the release. It causes a burst of energy, redirects bloodstream, relaxes respiratory tracts to increase oxygen gain and increases heart rate. The heart rate is what I'm going to log. I'm in an amusement park. I'll test the device on a roller coaster. It is 27 meters high. The top speed is 85 kilometers per hour. Looks frightful indeed. I fit myself in a cart and switch the device on. You can see my heart rate on the screen. The graph says I'm calm like an astronaut. Cover your ears, ladies and gentlemen. The test begins. Oh boy. Oh, come on. Oh boy, boy. Oh boy, boy. Mommy! Let's get it out! Ah! Oh boy. Oh, ay, 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 ay. The device survived the ride. The log says the heart rate started to increase back at the start, and the peak of 150 to 160 came around the time when the cart rushed down the drop. The heart rate stayed almost the same for the rest of the ride. For me, it was pure fun and terror. Like for you guys. Thank you.